So now we'll be showing a short demo of our Python application. So basically, once you install everything from the GitHub, you're able to run it as py-app.p or however else you run Python. And this is going to load a PyQt application where we agree with a search bar and a search button and with the ability to search. So for right now, we want promoters for optogenic. And we'll click search. And this takes about 1 to 4 minutes to complete.
So essentially what's going on in the back end at this point in time is the user input is taken and mapped using the LDA model. So essentially the LDA model, right, was trained play whenever it's done running. Perfect. So essentially here you can see that if you click on any of the articles that were brought up, again, sorted by relevance from the LDA model, you can see that parts were found in the paper based off of the Watson scraping model that we could use. If you click on it, you can see that you have the option to either export to GenBank, export to JSON file. Just for the clarity of the example, we wanted to show that all of these have different parts you can see that are being rendered. So for instance, if we have GFP, we can look at that. Go here. You'll also see that if you search enough, you'll find specific subtypes labeled. So you'll see here that the model was able to locate a gene, which is a subtype of a part that was located. So here, we're able to either export the JSON or the GenBank file. So if you export the JSON, it's going to give you all these parts in a JSON file. And if you export the GenBank, then for this specific gene, it's going to give you GenBank renderings. So we're going to let Ryan look on his computer to see if we can check out the exported files.
Okay. So first we'll take note of our PMID, which is 2483. So there we'll see right here, JSON 2483, and so if we check it out, we'll see that we have a JSON output of our parts in this in the paper.
Yeah, so you can see that we have parts like GFP, which are fluorescent proteins, GCAMP5. You're seeing some relatively canonical biological parts being represented.
Let's check out the other file. Several files.
Yeah, so from here, you'll see that we were able to essentially automatically take these that were scraped, map them to GenBank, and you're getting information based upon the amino acid sequences that are seen here. If you scroll down enough, you'll also see the actual genetic sequence we're able to get from these parts. So yeah, that pretty much sums up the demo.